don't think I've seen you before, Sarvesh. So welcome to the class. We use encoding to convert it into a quantitative problem. Okay, Sarvesh. I think you're on the right track. Take what you just wrote and take it just one step further. Take it one step further. But you guys are welcome to write about qualitative problems. How are we handling those? The authors, I think if I remember right, it's like a little subsection in one of their chapter sections. But what about qualitative problems? Okay, Hamad says agree with Sarvesh. So Hamad, take Sarvesh's answer one step further. What does it mean? What does it mean for everything we just discussed? What does it mean for the next slide that I have on qualitative problems? What are you expecting to find on that slide for qualitative problems? Ravindran says, I didn't get what's the question. Could you explain it, sir? So Ravindran, thank you for the clarification. Good job. A data scientist always asks for clarification. We know that there's quantitative problems when you're trying to do like some sort of like dollar value or something that's measurable, right? A scalar value. And we also know that there's qualitative problems where it's like a class or a category, you know, like when you're trying to do like a yes/no question, right? Those are two different types of problems in data science. What do the authors say about the difference between qualitative and quantitative problems and resampling? That's the question. Anybody else? A little bit less participation on this one, and I'm not surprised by that. Give everybody another 30 seconds or so here. I still see people popping in and out of Instagram. Love seeing you here. Thank you so much. Feel free to switch over to YouTube and you can see the widescreen format so you can see the entire class layout and all that. Sultan, question is not fully visible. Yeah, Sultan, I see that you're on Instagram. Feel free to watch us on YouTube. Data Science with Dennis is my channel. I'm live there now also, and it gives you a better view of everything on my screen, okay? But thank you for that feedback. Okay, Rex says, yeah, this question has me scratching my head. Okay, Rex, okay. All right. Okay, so I think I've given enough time. You know, Rex, I'm gonna just assume that you scratching your head is maybe rooted in suspicion, right? Because you guys know I like to give trick questions every once in a while, right? And this is a trick question. The answer is there is no difference. Right? There is no difference in qualitative versus quantitative problems when it comes to resampling. Because that theory, right? Remember these three steps, right? The data, here's my data. I'm going to try it against the model. Here's what my metrics say about my latest experiment. That's the same for everything, right? That doesn't change. Those three steps are a fundamental building block of data science, right? So it's a trick question. There is no difference for qualitative problems, right? So I want you to remember that what we're talking about is one of the most fundamental, most important things in data science. You should be doing this no matter what. You're going to be doing this really, I mean, for the majority of your career, all of your career, right? There will be no project where you're not using cross-validation, bootstrapping, resampling in general, right? Training cycles, right? This is the work that an algorithm goes through to build itself up, right? the repetitiveness of it, the experimentation side of it, you're always going to be doing it, right? So Rex says, yep. Yeah, Rex has attended enough of my live streams to know that I like to throw trick questions out there for you guys, right? So when I said, what does qualitative say about, what do I say about qualitative problems on the next slide? There is no next slide. I'm not gonna, there is no need for me to highlight qualitative problems because it doesn't change. You're always going to be doing this. There is no different training cycle for qualitative problems. So if we go back to Sarvesh and Hamad's answers about encoding it to convert into a quantitative problem, that's like a step in the process, yes. But there is no difference, right? You're still going to go through that same cycle, right? You're describing the tool to how to get there, and that's great. I commend you for that. It's an important part, and we cover this more in future chapters, right? The encoding side, I mean. But the process itself is still the same, right? Whether you're using a qualitative problem or a quantitative problem, doesn't matter. You're going to go through this over and over again. Okay? I want you guys to remember that. So, going to the next slide. Give me just a second to peek ahead. Yep. So, this here, this is what I would consider a model answer when somebody like me asks you in an interview, what is cross-validation? Right? It's the process the algorithm goes through in order to learn from the training data and create a model that can be used to predict future instances. That's what cross-validation is. Or you could say the same thing for resampling, right? That's what resampling is. There's different ways to pick the data, whether you're using k-folds or leave one out, but this is what cross-validation is. So don't confuse the two, because again, when I ask this, people give me a k-folds definition. But this is what cross-validation is, right? It's data science, right? It's one of the fundamental building blocks of data science. And here's another definition I've also used. It's like when you were in school and the answer's in the back of the math book, right? What do? You go through the problem, you try your best, you apply what your teacher told you, and then you go in the back and say, oh yeah, I got it right, or oh no, it went terrible, here's where I went wrong. Is that not cross-validation? Is that not what we just talked about? Right? The data. You tried your best to solve the data, to solve that problem. How did you do? You go and check the answers in the back of the book and you say, yeah, I did good, right? The process I just followed, the model I just created in my head for that math problem, it worked. I'm going to continue doing that because it worked. Or no, I did terrible. I need to fix my process. I need to adjust something, right? That's cross-validation. That's resampling. That's learning. That's training an algorithm, right? And the reason I give you these two slides is because maybe the first one maybe, but certainly the second one, this is what I use to explain to my stakeholders, right? This is how you should be talking to the business, right? I want to bring this all together back for you guys, because again, we're being professional data scientists, right? This is what the type of explanation I want a data scientist who works for me to be giving to the stakeholders, to the business, right? I don't want you talking in math and code to them. I don't want you explaining k-folds to them, right? They don't care how you're selecting the data, how you're generating your samples. Right? To them, you could be using a room full of monkeys to select your samples. They don't care. But this is how you should be explaining it to your stakeholders. Right? Because some of them, you're going to get this question. I've gotten this question hundreds of times in client meetings or with stakeholder meetings. Well, Dennis, when you tell me like it learns, like, what are you talking about? Like, how does it learn? What are you going to do? Right? Or sometimes, you're going to get clients who are aggressive. How do I know you're training this right? How do I know these crazy math algorithms are going to be correct?